Hello, everyone, and welcome to a new podcast. As many of you know, I have recently joined Stream Native, and I am looking for people in the community who are using Pulsar and other streaming products to talk to learn more about it. And today, I have a special guest. I have Frank Kelly from Cogito. Frank, how you doing?
I'm excellent. How are you?
I am great. I'm great. So, Frank, I know that Cogita uses Pulsar, but I was hoping maybe we could get a little bit more background on who you are, Frank.
Sure.
How did you get involved in the streaming messaging space? Tell us a little bit about your background.
Yeah. Well, my streaming messaging background goes back quite a ways. So, back in the old days of yore, I started off playing around with IBM MQ series, and that experience had gave me a lot of trouble of like lost messages and what happens if I can't connect to the queue and all these kind of like these challenges. And over time, future companies I've basically worked with ActiveMQ, JBoss MQ, always in a high scale kind of environment, either finance, telecommunications, social media, that kind of world. Eventually end up in the SQS, SNS, and Apache Pulsar has kind of been the latest and greatest thing I've been using.
So when we talk about messaging, and for we have lots of different people who watch this. We're talking about the ability to send data to multiple applications, to share data across different systems. um, Maybe if you could give kind of a couple of examples of things you've done in the past from a messaging perspective, just to give people some
Yeah.
context what that looks like.
Yeah, it looked very different. So there's kind of back in the JMS days, they talked about point to point and then pub sub, right? So point to point is, I'm putting messages into a queue for a single consumer that's going to read from it. So it could be, back in the days, we are doing stock price changes when we could actually keep up enough. So we put stock price changes into a queue, and then something would be reading from that and try to update a database. So that's kind of a point to point messaging. And pub sub is kind of these things are happening, and a number of people can find out about it. So again, in that kind of financial world, um, there we use Tibco, right? We put broadcast on these topics, and all these different things could be listening to it. Something might be updating the user interface in real time. Something might be trying to update a database. Something might be doing some analytics, and so that's another kind of messaging use case. And then, of course, then there's the whole streaming use case, which we also use with Pulsar as well for our case, which is new to me, which is basically there's a continuous stream of binary information, and that's a whole separate kind of use case.
Yeah, so instead of just one message, fire it off, be done, now
Right.
it's always on, always coming in.
Yeah, and the challenges around that are, especially if it's a binary stream, not something structured like JSON, then you can't afford to lose a message, and you can't have duplication because then the binary becomes unreadable, it becomes garbled, and that's one particular area where, for us, Pulsar has really shined. Is that I can't think of a single case in the last 2 years where we lost a message or had a duplication. It just works.
Well, that leads to the question, working for Cogita, maybe for those who don't know what Cogita does, can you tell us a
Right.
little bit about Cogita and
Yep.
how you're using Pulsar?
Yep. We are a 12-year-old startup, originally out of MIT, and we build emotion and conversational AI to build a contact center solution. So we're listening in basically on contact center agent phone calls, and then giving them behavioral nudges and suggestions at different points in the phone conversation. It could be as simple as you're being very quiet for a long time. Often agents are often typing stuff into a computer, and they forget the fact that they're on the phone, and it's all gone quiet. It could be something as picking up, the customer is clearly very upset right now, so we can give them advice on, tailored advice on how to handle that in the moment. We can detect if people are talking over each other, and so we kind of do that to build up, and not kind of a you're a bad agent type of deal, but kind of a friendly guide to the agent to help them. We find that agents are actually quite good at their jobs. This is about giving them a little extra boost, and also giving the supervisors insight. So they're managing tens of agents. How are they doing across multiple business lines, different goals, different teams, and then executives look down across everybody. It's like, how are things going? Are we getting, are we improving our behaviors
Oh yeah.
And ultimately, there's the net goal is cost improvements really for the company, also working on their brand. So we work with telecommunications companies, healthcare companies, finance companies, companies that are very protective of their brand or who have a very complex relationship with people because the laws are complex, and so there's often complex and very weighty conversations going on.
So you have someone who's talking like we are. So let's use this as an example. So we're recording audio. We're actually doing this live right now, and it's going up to the server that we're using, Riverside. And so as we're recording, you know, your Cogita's basically would be then sitting here and listening in and being able to take this live as this is streaming in and
Yep.
be able to say, oh, Matt, you haven't said anything in 30
Right.
seconds. You should probably ask another question.
Yeah. Yeah. So I mean, this is the really interesting part is that we have very high response time SLAs, very high, very low response time SLAs. They're high bar to meet. And so we're basically trying to get the audio, send it over the wire, send it to our compute and our AI back end systems, have them process it. And AI is very computation intensive, um, and then pull out events, send those back to Pulsar, and send them up to the user interface, all within 250 milliseconds. So
Yeah, and
it's
250 milliseconds. That's nothing to sneeze at. I mean, when
that's
we
right.
talk about like millisecond times, those are difficult, especially when you're talking about cross the wire. You're going across data centers. You're going to potentially individual machines with people sometimes working from home.
Yeah, that time certainly adds up. And one of the other challenges is we're looking now at contact centers that have thousands, tens of thousands of registered agents, of whom 5, 6, 7,000 could be online at the same time. So we are doing high response time and massive throughput as well. So it's
Yeah, that's got to be a lot of throughput because when we talk about like processing text can be big, but audio is bigger.
yeah.
So what sort of sizes are we talking about?
So we're currently doing audio. It's around 32 kilobytes per second, which is not a lot, but again, you multiply that by thousands of people, you're talking easily gigabits per second, that kind of speed. And thankfully, that's areas where pulsar compression is a lifesaver, and we can compress it on the client side with very little overhead, and then just transmit it through. And we're always willing to pay for the CPU because the I/O it really is expensive.
Well, and that's something that, Pulsar does have a pretty good model of elasticity, right? So the ability to spin up additional workers and consume, CPU differently because Pulsar's architecture is a little different than other messaging systems where the compute storage is broken up.
It
So
is.
yeah, and so are you spinning up additional workers as the workload increases? So if you have 5,000 people online now, and then all of a sudden it jumps to 10, then you just start spinning up additionals.
We want to. We certainly want to get there. We're actually testing it now with the Pulsar auto scaling, load balancing, and
Okay.
one of the things we often find is it's often said that the brokers are stateless, and it's really not true. And so we find that as we these namespace bundles, so Pulsar breaks a namespace of a bunch of topics into shards, if you will, also called namespace bundles. And those namespace bundles are assigned to brokers. And those things will basically, as you add more brokers, they have to move around to balance that load. And in that moment they're moving, we could have active topics talking to one broker, and all of a sudden now they got to talk to another broker. And so what we're finding is the clients are able to recover, but not able to recover fast enough for our use cases. So we're kind of working with the folks at Stream Native to kind of optimize that and to detect things faster, fail over more quickly.
Okay. Yeah, and I think that, like that's not a unique problem because as you scale any sort of messaging system, you have similar challenges. And I think architecturally, Pulsar allows a little bit more flexibility there. It sounds like there's some work that needs to get done.
Yeah.
I know, like when you're talking about the older kind of, whether it's an ActiveMQ or Rabbit in some cases,
Yeah.
or even a Kafka, there might be other limitations that are exposed that are a little bit different. So
Yeah.
I think that as we start to scale up, we start to run into those,
Yeah.
really deeper problems at mass scale. And,
Yeah.
you're talking tens of gigs of data a second potentially on your side.
Yeah, yeah. And people often talk about scaling is easy, and a lot of the solutions out there are really about stateless scaling. So you've got servers that are stateless and talking to databases where the state is. But scaling stateful storage has been, at least in my experience, is extremely hard. And so it's, whether that's relational databases or to, high end key value stores like Dynamo and stuff like that, it's very hard to get it right, and you really need a lot of investment to get that optimized for a number of different use cases.
So were you at Cogito when they implemented Pulsar initially?
Yeah, I was there from the beginning. I wasn't there at the moment it was chosen, but
Okay.
the criteria that we use to choose Pulsar were really, first of all, multi-tenancy support, which will be great for us in terms of cost savings. The encryption authorization built in, which is fantastic. The scalability story that they had was really awesome, and the support for all those clients. So we wanted to go from kind of a monolith to a microservice architecture where we wanted to be agnostic about clients. We didn't want to spend all our time writing clients for something maybe we wanted to have, and so having the Java, Go, and Python clients ready to go was really important for us too.
Okay. Were you so since it was a startup, you didn't have a lot of legacy code though that you had to worry about either rewriting, did you?
Well, we did. I mean, the
Okay.
challenge was really that we had a number of customers on our platform one, as we called it, and we
Okay.
wanted to migrate them to platform two. And so we were basically, I don't know if you know the story about the big dig in Boston, right? So, there's that, probably a lot of people don't know. So basically, we used to have this, raised highway going through Boston, and decided let's replace it with a tunnel. And so they had to basically dig this massive tunnel under it while keeping the thing running on top. That's kind of what we did. We basically put a bunch of interfaces in front, kept the user interface working against platform one and platform two, and then basically, implement everything exactly the same underneath the covers with some switches. And so that was pretty interesting and pretty challenging, but we've been successful.
Now you talked about multi-tenancy. Um, you know, for a lot of people, multi-tenancy, um, if they've got one app, they might not think about it, or even if they have multiple apps that need data, they're not necessarily thinking about the segregation.
Right.
You mentioned cost savings there as a potential reason. Maybe talk a little bit about that multi-tenancy and why that was attractive.
Yeah, I mean, we have a number of different customer bases out there. Some are larger, some are smaller, and apologize for the things going on in the background. But yeah, so for some of them, again, with any environment, we're setting up databases, we're setting up Pulsar with its zookeepers and its bookies, and we're always saying, well, for high availability, we want at least 2 broker pods, and we need a quorum in bookies, so I need 3 bookie pods. I need all of a sudden I've got 9 pods. So I've got 3 zookeepers, 3 bookies, 2 brokers, and 2 proxies. So maybe that's 10, right? So I've got 10 pods right off the bat, and I need them to be pretty snappy and responsive. So I've given them some CPU shares and some memory. And if that's for a customer base where you've only got like 50 or 60 customers online, that's pretty expensive to run. And so what we're trying to do is basically put clients together. They're logically separated, logical, that's the exact term, logical tenancy, if you will, in that environment. So they're in separate, they're in the same Kubernetes namespace, but different Pulsar namespaces with other controls. And
Okay.
we can use that to save money, basically. So that those 10 pods can work for like 5 customers rather than just one.
Yeah, so operationally, it's more efficient because there's less to manage, but also, you've got the ability to use less hardware and less, you know, components. So, okay,
Yep.
yeah, that totally makes sense.
Yep.
And so, part of that is also the security of it, making sure that the data is segregated, which is nice to have that capability built in because that's
Right.
an absolute requirement as well.
Yep.
Yeah.
Yeah. So security is always key. So like all our EBS drives are encrypted. We're always making sure that we have proper controls, authorization, authentication within our Spring applications and elsewhere. One of the good things we did, we used Istio as our service mesh, and we were able to bolt that on with Pulsar to make sure that there's some pretty strong controls around it. I mean, Pulsar has its own authentication authorization mechanism, but we just didn't fancy spending a lot of time injecting certs and doing MTLS when Istio will kind of do that for us, and it's been pretty successful.
Oh, cool. Yeah. So you have a team of developers who are using this and they're building on it and they're enhancing it. Um, Maybe tell me a little bit about like from your role when you have developers who are coming on. What are the things that they find either interesting or like odd about Pulsar? Are there
Yeah.
those things that you have to kind of explain the topics
Oh
or
yeah.
explain what's going on?
subscriptions. That's what I find is the
Okay.
first thing. So I remember my first day playing with Pulsar. All right, I created a topic. I wrote a message. I created a consumer. I listened to the topic and nothing. What? I'm like, I'm used to queues. I write something to a queue, it stays there. I read from the queue, it's mine. I'm like, what? I'm like, spend hours. I'm like, what? So that's the big difference, right? Is that if the subscription wasn't pre-existing, then you're not going to get the message because the default for Java, at least, I think, is to get latest message. So the minute you start, if I send a message at time 0, I try to consume at time 1, it says, give me all messages from time 1 forward. And so you basically have to tell it, all right, you got to go back to earliest to get all the messages. And that's when I started learning about subscriptions. And then, there's these things called backlogs, which sound like they're a queue backlog. They sound like there were a bunch of stuff in a queue, but they're not. They're just like a logical marker. And so that's pretty confusing to people. And that part is the first part to get over is what does the backlog mean? What does the subscriptions mean? From an operational standpoint, the subscriptions are a little bit challenging too, because other people can create subscriptions that are durable. They last forever. And if they last forever, you will never delete that data, right? That old subscriptions hangs around, then Pulsar says, well, if they haven't caught up, I'm just going to hold on to that data just in case they come on, on Tuesday, decide to catch up. But it's a problem for retention because all of a sudden I'm paying pretty dollar for all this EBS drives. I'm like, where's all my disk space going? It's like, okay, we got a rogue subscription out there. I'm gonna delete it.
Yeah, no, I mean that can be. I think anytime you change how you've thought about building an application or how a piece of technology works, it's often difficult to make the transition because you just fall into old habits.
That's right, totally. And so you start thinking this world more of a streaming world of, there's multiple people at different points in the queue, if you will, in the topic. Then it becomes a little bit easier to understand. And then,
yeah, and we were chatting, kind of in a pre-call about one of those other things, which is like the negative acknowledgement and how developers are like, what about my exception handling?
Right. Yeah. I mean, exception handling is always hard. I used to do this with MQ series back in the day. And it was like, I got a message. I can't handle it. I can't write to the database. Oh, what do I do? And that's what we were doing is like write into a dead letter queue that somebody else pick it up. I'm like, okay, now I've just created another software development problem. And I've got to reach to another queue and figure out how to handle it. And what if somebody else already picked it up? And so the nice thing is Pulsar gives you this knack ability, which is if I can't handle it, just you can either not acknowledge it and the timer goes off, in which case the message will be delivered, or I can negatively acknowledge that I can't handle this right now. Somebody else can go handle it. And so you can kind of basically say there's some errors that you can retry on and some errors you can't. And so the negative acknowledgement lets you handle that, which is kind of nice because there's times where we're trying to basically, maybe offload data to S3 and, something happened for whatever reason. We couldn't, the database was slammed and we couldn't get where the location was. And then it'll be retried 15 times, which we have configured. It's like, every 10 seconds. And then, if it doesn't work, well, then we have an alert. But, having the retries automatic give you kind of a lot of flexibility.
Oh, that's cool. Yeah. And, one of the other things that, I've been reading a lot about is, the high availability, setup and, the geographic replication available in Pulsar are, I'm assuming that there is some, geo-specific things that you're doing and you are potentially taking use of that. So maybe tell us a little bit about what that high availability looks like for you all and how you achieve that, especially at the throughput that you have.
Yeah.
That's got to be an interesting, recovery time.
Yeah, it's a great question. We really tend not to use geographic replication. So we just deploy really in the AWS region that's closest to the customer. So it could be US East, EU West 1, that kind of stuff.
Okay.
But in terms of HA, I mean, we're always trying to be aware of, Zookeeper has its own HA, right? So it's got to be 3 pods. But then the question is, how are they spread out across nodes in Kubernetes and then across availability zones? So the Pulsar chart, the Pulsar Helm chart has a bunch of anti-affinity stuff. So it's certainly spreading things out across nodes. And then, one of the things we have to still kind of go back and work on is that also spread out across availability zones? And my guess is it's not. And, we definitely that's something to work on for Zookeeper, and certainly on the bookies as well. It's even probably more critical. But the fact that if the Zookeeper fails and bookies don't, it might as well be the same thing, because we found that once those two things get out of sync, we're kind of hosed. Brokers are they're stateful, but a little more recoverable. So yeah, I think the HA is really having multiple pods spread out across nodes, but the area to work on is the anti-affinity, so breaking it out by availability zones.
Okay. Well, and so you've been working with Pulsar for a while now. What's your favorite feature?
What's my favorite feature? There's so many good things. So just last night, I was did a production change, and I just turned it on and I listened to it, to the audio streams. Just log in as a user and kind of listen to phone calls going on. It's just seamless, right? So we're basically listening to the audio stream, chunking it out into separate messages. It's kind of like Willy Wonka, that Mike TV moment. Do you remember that, when he like rips the kid apart, puts them up in and we're pulling it all back together again. But it's seamless, right? And it's just listening to it, and it's just like, I can't believe that's 8 messages a second, and it's just seamless. There's no glitches. There's no,
Just how it all works together. Then really is that
works, yeah. And so that's working with compression and authentication, and all behind the scenes going across, multiple VPCs, and into memory and onto disk and then back out, and then it's kind of like, it's pretty cool. It's pretty cool. It just worked. That part, it just works. The compression is awesome too. I mean, that we just turned that on, and we got like a 3x improvement in a lot of our performance benchmarks and IO and.
Oh, really? Wow.
Yeah,
that's a pretty big savings.
Yeah, I guess WAV isn't as efficient as one would think. There's certainly other audio formats that we're looking at that will be compressed by default, but it was kind of nice to get that out of the box, because we were looking at staring down 500 megabytes per second, and all of a sudden we just went to 150. It was like, yeah, sweet.
Well, yeah, that does reduce the costs and the bandwidth there. Yeah. So as people are deploying Pulsar, and as your users or developers are starting to use it, is there a common problem that continually comes up, an issue that you see over and over again?
Common problem. I'm not sure there's a common problem, but there's a common piece of advice, which is Pulsar exposes a whole bunch of metrics for Prometheus, and that you really need to graph those. And so there's a bunch for the proxy, the broker, the bookies, the Zookeeper. That will be your lifesaver. I mean, for us, we're kind of somewhat of a unique use case in the sense that we're doing a lot of these binary streams and stuff like that. So for us, we're kind of really monitoring broker ledger caches and that kind of stuff. But in terms of stuff goes wrong. We had an issue this morning, right? We all of a sudden our bookie response times went through really high, and so Prometheus alerting kind of goes, "Hey, your bookie response time P99 just hit 30 seconds." I'm like, okay, that's
wow,
not good. That's not good. What the heck? So we looked at it. It was like, it was a big read load. Where did that read load come from, right? And then having those tools to track that down, because between the proxies, the brokers, the bookies, the Zookeepers, your drives, all the pods, debugging is going to be hard. And so, upfront, invest that time in, whether it's your Grafana charts, alerting, know what goes wrong and alert on it, and be ready. Because that's the hard part. And we also run books, right? It's like, hey, if you see this alert, look here, because you're going to get it at 3:00 in the morning, and you're kind of going to go, I'm not caffeinated. What do I do? I'm like, okay, I wrote myself a run book. Okay, dear Frank, here's what you're supposed to do. I'm like, oh, thanks. So,
yeah, So, and Frank, I know you were going to speak at the Pulsar Summit, but you couldn't make it this year.
I know.
What was the topic you were going to give?
So it was basically, I gave a topic the prior year, and it was more of things we discovered. So first year was all about, we discovered so this is another little thing they always say, well, we write to the journal, but you read from the ledger, right? And it's like, and the two never really meet. I'm like, well, they have to, right? The journal has to get written to the ledger. And so we learned that if you're reading from the ledger at the same time as you're trying to write to the journal, right? As the journal's trying to write to the ledger, you're trying to read from the ledger, you can basically jam up the bookies. And so what we learned was, again, we're in this fortunate or unfortunate real-time case. if we made the broker caches really big, then we would just read from the broker cache and never hit the bookies, and then all of a sudden our throughput was off to the races. So that was one big positive from
Mm.
2021. 2022 was when we realized that we would be creating a lot of topics, very, very quickly. And for that, we needed to improve Zookeeper, and a lot of the response times there around Zookeeper and scaling Zookeeper. And so Zookeeper has a number of settings, some of which are just now available to improve that scalability. So that metadata, Zookeeper is a metadata store, keeps track of all the topics, and as they're created and deleted, it gets quite a bit of load. And so that was key there to monitor that.
Yeah, so I mean, it's just really about the scale. Now, you mentioned like you're creating a lot of topics because you create a topic per phone call.
Yeah, so for every phone call, there's two topics. There's one which is the audio, and one which is the analytics. And we had multiple debates about this, about what the way to go. And we wanted to do maybe shared subscriptions and big fat topics, and that was kind of the suggestion. But what we realized with the kind of big fat topics is our AI algorithms are kind of small little pods, thousands of them, thousands and thousands of pods, and they were just like, I want one audio stream and I'll produce one analytic stream. Great. The problem is if you have one big fat pipe, that fat pipe of IO would have to go all to the that single pod, and it would only have to pick like 1/1000th or 1/5000th of that IO it would be interested in. And so I know there's talk in future for doing some filtering basically on the server side, but we felt it was just easier to manage and go live. We had one topic per audio stream, and then it worked out pretty well. But it's not the default setup for Pulsar to think about that. So there was a number of settings we had to tweak. You can find my talk from 2021 about that. But as with everything in Pulsar, there's a setting for it. You just have to find out what it is.
Yeah, no, and it's interesting because it goes to show you, as you're building out applications, especially as you grow and scale, oftentimes you need to think about the workload and optimize, the infrastructure for the workload, not just on the setting side, but in your case, you're like, oh, well, one topic, per phone call makes a lot of sense for us.
Yep.
That's not something that you would necessarily think about, but I think that as we start to think about like the future of, how things grow, how things evolve, those are the types of design decisions that a lot of people might not realize they need to make early on or as early as possible.
Yeah. I was just thinking today, it was like, if there was a lesson I'd learned in 20 plus years, it was like, don't front your database with the queue, because you can jam messages into your queue faster than you can jam them into the database, those kind of things. But you really have to be aware of the rough order of magnitude of each thing, right? So databases, you're talking about, say, a 10 millisecond insert time. Maybe not if it's locally, or maybe it's not, Memcache might, it's 1 millisecond, whatever, but that'd be different. But then you got to understand the order of magnitude of things. And we can jam tons of messages into Pulsar. We're like we have record everything. We're all like, Pulsar send times is like less than a millisecond. I'm like, yeah, you can really, overwhelm things downstream if you want to with Pulsar as the front end. So you really have to be aware of proper choices of storage, and not just for like scale, but also cost, right? So we were trying to jam stuff into our bookies, and then we realized, let's just pick GP3 drives. They're really, really fast, and they're inexpensive compared to IOPS optimized, the IO2s, and it was expensive. We're still paying a lot of money, and we realized, well, if we just add more bookies and had GP2, we could achieve the same scale with less cost. But yeah, you have to really be thinking about the relative order of magnitude of those bits. Again, if you're just sending a couple of messages around, every couple of seconds, you're not too worried about it. But if you're really at the high scale world, you're going to be living and breathing.
Yeah, there's a fine line between over or early optimization or future proofing, like spending too much time there and not spending enough time.
Yeah.
And that's a whole interesting, debate and discussion. But
yeah. I think layering, make sure you have the proper interfaces so you can swap out implementations is always important. That's one of the things we're also going to do as well. Is we have our telephony systems and our compute systems are directly tied into Pulsar with the library that we wrote. And now we're like, you know what? We want to pull that out and abstract that away, just because, we're we're often like, oh, we got to change the library and add this little setting, and then it's got to go to our telephony team, and then they have to deploy it, and I'm going to make sure that's deployed everywhere, and that's the thing we have to organize. So, well, if we had an interface in front that was abstracted away, then that would be a lot easier. So,
Oh, very cool.
yeah, well, a lot of lessons learned. Good stuff.
Well, Frank, I want to thank you for spending some time with me and telling me about how you're using Pulsar, helping me learn a little bit more about how people are deploying it and using it, and some of those things we got to watch out for. I really do appreciate it.
Not at all. Thank you very much. It was an absolute pleasure.
All righty. All right, we're good.